Okay. Recording. Good. All right. Now again, I know some people like to see all the steps. That's the next slide here. Okay. You know, again, you take the x minus 1, you put it out, you divide, because you have to see what's left over. And when you divide, remember, what do? You divide into each term. And here, of course, there's cancellation, right? You have x minus 1 cancels with x minus 1. That's from the first quotient. From the second one, x minus 1 cancels with x minus 1. So we're left with x minus 1 times 6x plus 7. So that's what we get here. And again, we get the same answer. So, I mean, it doesn't matter what order you write these in because you're multiplying. So, all right. What questions do you have about this? If any. If you don't, that's okay. But if you do, don't be afraid to ask. I really hope this is making sense. You know, that's what I want. I know these problems are not easy. I understand. So I was a student once. I know these are not easy to do. All right. Well, before we do another one, I just want to present some factoring, vocabulary. You know, math is like any other science. There's going to be some terminology, specialized terminology, that is. Well, for any polynomial, just like with any integer, there's always at least one way to factor. You could do 1 times the integer itself. And likewise, for a polynomial, you could do 1 times the polynomial, or -1 times negative the polynomial. Those factorizations are trivial factorization. They're called trivial factorizations. Mostly because they don't tell us, they're not really useful. They're not really helpful for us. You know, generally when we factor, we want to break up the polynomial into smaller pieces, smaller in the sense that the degrees is less, but those pieces have to serve a purpose. They have to be useful somehow. And you don't get that when you have these trivial factorizations. I know when you're trying to graph polynomials, factoring helps you a lot with graphing and seeing how the graph behaves. It's one of the benefits of factoring, one of the many benefits. Okay, that's good. Now, it can happen, though, that the only possible factorizations are the trivial ones. You know, it's possible that those are the only factorizations. If that's the case, we say the polynomial is irreducible. So a polynomial is irreducible if the only factorizations it has are the trivial ones. That's good. And so we can actually obtain some irreducible ones. Namely, if you have a trinomial like this, and there are no factors of a times c, no integers that is, whose product is a times c, that add up to b. So if you were to try the AC method and it doesn't help you, then it's irreducible. The polynomial is irreducible. And these are just some other examples. If you have if A and B happen to be non-zero integer, well, I guess here they would be non-zero integers, and they have no common factors except 1, these are going to be irreducible. Here you have a sum of squares, here you have ax plus b, but again, you can't factor anything out because A and B have no common factors. And just to make it a little even more specific, x squared plus b squared, this is irreducible for any b, non-zero. X plus d and x minus d, that's also irreducible if d is non-zero, if for any number d actually. Okay. So those are just some specific examples of irreducible. Let me see. Okay, those are just some specific examples of irreducible polynomials. Now, here's some more vocabulary. A polynomial we say is reducible if it's not irreducible. So it's either irreducible or reducible. And basically, it's going to be reducible then if you can factor it besides a trivial factorization. So it has a factorization besides a trivial one. Now, to factor a polynomial completely, that means you want to write it down as a product of irreducible factors. Basically, you can factor the polynomial until you can't factor it anymore. That's essentially what it means to factor the polynomial completely. You keep on factoring it until you can't factor anymore. And you can always write it as a product of irreducible factors. I mean, how do you prove that? That's way beyond the scope of the course. I think the first time I ever saw a proof of that was in graduate school. But it turns out you can do that, though. All right. I mean, that's just some vocabulary. I'm not going to give you a vocabulary exam in this class because the exam's a take home. So, okay. All right. So let's do another one. Now, this one you're actually going to see that the GCF, it is useful to factor out. It does make the problem a little bit easier. All right. So right away you can see that m is 1, okay? Right? M is the smallest exponent of x, so that's 1. Now what about the coefficients? Well, we have 30, 155, and 25. I mean, to get the factors of them, 30 we have 1, 2, 3, 5, 6, and so on. For 25, that's just 1, 5, and 25. For 155, right? You have 1, you have 5, you have 31, and 155 itself. You just keep on dividing by something that's a factor of it. And that's how you get all the factors. So as you can see then, right? You can see then that the greatest common factor among the coefficients, looking at these lists, is 5. 5 is the biggest common factor. So that tells us B is 5. The GCF then is 5 times x. M is 1, remember, right? So M is 1, it's 5 times x to the 1, which is just 5 times x. So as before, what do? We factor out 5 times x. To get what's left over, we divide. Okay? And when you divide to each term, as you can see. Here we go. So you divide to each term, as we see. And when you do that, this quotient here, 30 over 5 becomes 6. X cubed over x is x squared. 155 over 5, that's just 31. Don't forget the minus. X squared over x is x. 25 over 5, that's 5, and the x's cancel, so we get this. So now, what do? We're going to factor this thing in parentheses, 6x squared minus 31x plus 5. That's what we factor. And notice that's a lot easier, right? The numbers are smaller. Not to mention, it's now a trinomial that we can use the AC method on, right? Before, we had a trinomial, but the degree was 3. Here we have one of degree 2, so we can use the AC method.